Hello, uh, I'm Dr. Stavros Shiaeles, and I am Associate Professor in Cybersecurity at the University of Portsmouth. Uh, this is my keynote presentation, which is called Detection of Low-Level DDoS Attacks, Low-Rate, sorry, DDoS Attacks based on TCP connection parameters, which is for the conference SEML 2024. So I'm going to see research objectives, methodology, results, discussions, and finally, I will provide you my details if you have any questions or you want to ask anything. Feel free, or collaboration, feel free to contact me and discuss further. So what were the research objectives for this experiment? Basically was to detect application layer low rate DDoS, distributed denial of service attacks through TCP flow metadata analysis through some machine learning algorithms. So why low rate? So the reason of low rate attacks, it's a very interesting subject, which, okay, the DOS attacks, they were studied a lot. However, low rate DDoS attacks, they were studied, but not in such extent. And the main reason of this problem, of the study, of the lack of study, let's say, is because these attacks, they are behave like legitimate users. So it's very difficult to identify if it's actual attack or if it's a user, a legitimate user. So blocking a legitimate user thinking that it's an attack is not wise, and it's something that you don't want to do. So this specific research was focusing on HTTP and specifically on HTTP traffic. So the idea was to try to identify in this HTTP traffic legitimate request from malicious request in order our intrusion detection systems to be able to uh, identify them. As I said, it's very difficult this to be uh, tackled because there is high similarity of legitimate web traffic with the malicious traffic. So what we did about that, first of all, we set up a simulated network. The simulation here, as you can see, it was set up using GNS3 as well as containers. So we have the GNS3 plus containers. We have a web server that it was handling the request, the HTTP request, and through the networks here we have legitimate users plus malicious, as you can see, attack nodes here, which they were attacking this web server. Uh, so that was the setup we had. The web server we configure for this experiment, was an Apache 2.4 server, and we had also a MySQL database in order to and PHP to have a website and show some response to the users. And this web server Apache was running 5 different websites. The legitimate activity was simulated and configured to randomly select URLs stored on the website. We also simulate the HTTP post method by sending data to the MySQL database. Also, in addition, we have to traffic passing to the traffic. In addition to the traffic, was passing through at the unrestricted rate of 1 gigabps per second. The scenario also included emulated slow connections by applying traffic shaping and throttling traffic to 11,520 bytes per second for some of the connections. This scenario was included in 84 hours of traffic generations to include several types of attacks, and these kind of attacks are summarized here in this table. So we have these kind of attacks and this type of legitimate. You have here the duration, the nodes that we use, and how much TCP flow we could collect. Also, in order to have more traffic, we use the CIC datasets, which we uh, use it in conjunction with the actual traffic that was creating in this network. The resulted traffic was collected in pickup format using the Wireshark on the network tab, it was between the web server and the switch. The pickup files, we then, after we collect them, we process them using TCP trace. From there, we extract the TCP connection parameters. As you can see here, we have many flows collected. We have attack flows, legitimate flows, etc. And we have constructed 4 different datasets. Each of these 4 datasets, they have a slightly different, let's say, uh, data. So dataset 1 represent a balanced environment with an equal amount of legitimate and attack simulation flows. Dataset 2 and 3 are to determine whether using a simulated environment has an impact on the accuracy of the estimation. And finally, the dataset 4, we use it to evaluate the ability of the classification algorithm to generalize across a mix of simulated and real traffic by combining the legitimate traffic in the CICD dataset with the traffic from the simulated run. The next step of this research was to see the feature selection with distribution. We had 142 possible features, and we used, in order to improve the detection, we use the recursive feature elimination with tenfold cross validation, in short, it's called RFECV, along with SVM, in order to figure out which features are the most prominent and they do the most uh, difference in the detection. After these 142 features, with this feature elimination method, we managed to stay in 20 features, which they can show here. So we have the this is the 20 features, and here you can see some prominent features we had from the results. This is the feature elimination method, the RFECV, which this is an automatic method which analyze all of the features and correlate the features between each other in order to uh, find the best values available. So after we figure out the features, we use six classifiers from the literature, the most, let's say, well used in the literature review. So we use logistic regression, LG, KNN, SVM, decision trees, DT, random forest, and deep neural networks. The aim behind this wide range of classification was to determine uh, whether the choice of the specific classifier does have a significant impact on the detection of the accuracy, and the accuracy will be mainly due to the selected set of features. Uh, we implement this using TensorFlow machine learning framework, which allows this automatic workflow of data processing. As you can see here, even if it's in the next in the discussion, we have various in the dataset we have various outputs, and you can see from the results that we have a good accuracy here in KNN, in SVM as well, comparing with and random forest, comparing with uh, neural networks and logistic regressions. So, as I said, we have these six classifiers. Uh, the tests were done in these four datasets, as we said. Dataset one was used to observe how an equal mixture of legitimate and attack traffic would impact the classification. The results show, as you could see before, that uh, we had an excellent performance of KNN decision tree and random forest. Given the results are based on tenfold cross validation, the results do not suffer from overfitting. The exceptional low false positive rate and false negative rate of the decision tree in KNN indicates a value low enough to use with an ITS or an IPS system, and demonstrates the potential of automatic IP blocking for low-level DDoS, from low-rate DDoS prevention systems. Um, In terms of testing, we use this for 1 to 3 data set. They had one half training test radio, and dataset 4 had a 10-90 test training split testing. So the primary aim of the research was to ascertain if machine learning using TCP performance as a feature could employ to detect malicious low rate DDoS attacks uh, among legitimate activity, which, as I highlight in the beginning, they tend to be very similar. Uh, so the results show that the validation tests that we can easily categorize, not easily, we can with really good accuracy, reaching 99%, we can uh, categorize this traffic through analysis of these results. I said we had 99.9% accuracy. However, the complexity of neural network did not outperform the lightweight machine learning algorithm like KNN and random forest. Uh, the so based on the features, so we manage to reduce the features first. So that reduction basically is needed in order for the system to act faster. Plus, we use various algorithms, machine learning, so we manage to uh, speed up the detection process and also lower the resources needed for detection. So that was the idea of this work. If we could be able to detect low rate DDoS attack, which with less features instead of more features. So I consider that this was achievable. Moreover, another addition of this lightweight algorithm is that the they are significantly easier to be trained and to be tested comparing with neural networks, which again this is a very important aspect of this research that we have. Also, as I highlighted before, they had a really, for example, in dataset one, we have a really low false positive and false negative rate, which this is another important factor that we wanted to explore in order to be used with the modern IDS system. The main limitation of this research is that the fact that it was carried out entirely on 2 datasets um, based on simulated attacks, which may be, let's say, be perceived as slightly biased. Lack of parallel GPU processing capabilities consequently led to lower epoch and higher learning rate than will have been optimal for achieving the best accuracy level. Volume of that data is also an important aspect of machine learning for training, testing, and validation, especially in neural networks. So more data could result that models could be created that could be applicable to a variety of service setup and content. So future goal will be to to involve using a wide range and larger volume of real world data, use cloud platforms, GPUs, so we can study more thoroughly the neural networks, or adding some more features in neural networks and play around to see if they behave better, or some other machine learning algorithms or bioinspired algorithms. This could be more extensions of this work. So thank you for your attention. You can mail me here if you have any question or you want to collaborate in some research.